Freezing point depression and boiling point elevation of electrolytes. Colligative properties like freezing point depression and boiling point elevation are impacted by the number of particles in solution, not the identity of the particles. Electrolytes like NaCl, table salt, dissociate or form ions in solution. Thus, N is the number of particles formed in solution per 1 mole. For non-electrolytes, N is 1 because non-electrolytes do not form ions in solution. For electrolytes, N is the number of particles formed in solution per 1 mole. For example, sodium chloride forms Na plus ions and Cl minus ions in solution. N is equal to 2. Aluminum chloride, AlCl3, forms Al3 plus ions and 3 chloride ions in solution. N is 4. Calcium phosphate, Ca3PO4 taken twice, forms 3 Ca2 plus ions and 2 phosphate ions, minus 3. N is equal to 5. For example, what is the freezing point of a 1.75 mole solution of boron chloride, BCl3, and electrolyte? N is 4. Boron chloride, BCl3, is an electrolyte and dissociates in water to form B3 plus ions and 3 chloride ions. The freezing point constant for water, Kf, is a negative 1.86 degrees Celsius per mole of solution. M is the molality of the solution, moles of solute per kilograms solution. The change in the freezing point is delta Tf. Tf is the freezing point of water in this case. The change in the freezing point of water is equal to N, which is 4, because boron chloride and electrolyte will dissociate to form 4 particles, times the freezing point constant, which is a negative 1.86 degrees Celsius per mole solution, times 1.75 mole, which was given in the problem. The change in the freezing point is a negative 13.02 degrees Celsius. The actual freezing point at standard conditions is 0 degrees Celsius plus a negative 13.02 degrees Celsius is a negative 13.02 degrees C. Calculating the change for the boiling point elevation works the same way. The only difference is the boiling point constant. N is 4. Boron chloride, BCl3, is an electrolyte and dissociates in water to form B3 plus ions and 3 chloride ions. Kb is 0.515 degrees Celsius per mole solution for water. M is the molality of the solution, moles of solute per kilogram solution. The change in the boiling point is delta Tb. Tb is the boiling point, in this case water, at standard conditions. The change in the boiling point is N, which is 4 because boron chloride is an electrolyte that dissociates in water to form 4 particles, times the boiling point constant, which is 0.515 degrees Celsius per mole solution, times 1.75 mole, which was given in the problem. The change in the boiling point is 3.61 degrees Celsius. The actual boiling point for water at standard conditions is 100. The actual boiling point, when you add boron chloride to it, will be 100 degrees Celsius plus the change in the boiling point, which is 3.61 degrees Celsius. So the actual boiling point will be 103.61 degrees Celsius.